which is the Marconi project, another Texas Institute-sponsored project. And if we could, at the time that they start their Q&A team, if the next team could come on down so that you can take the stage right after. And that will be the Erickson team for UTDesign 1, simultaneously streaming linear and nonlinear data analytics. So you can take the stage about just a few minutes before others. So let's welcome now the TI team that's doing the Marconi project. Welcome.
We are from my team. My name is Ben Morris, Jada, Robin, Justin, Steve. We are doing the Marconi wireless transceiver project. So this year alone, Cisco estimates that per month we will have used 2.4 exabytes of wireless data. Exa is 10 to the power of 18. So that's an incredible amount of data that we're downloading over our current wireless network. And in 2016, they're estimating a use of 10.8 exabytes. As you can see, this problem is just getting bigger, and our networks are becoming overloaded with high traffic. Not only are they overloaded with high traffic, due to power constrictions and tower placement and things like that, we have limited coverage, like in the ECSN lab, we have no service. And then we also have limited capacity as well. So the solution to this problem is, one solution is small cells. And in particular, small cells that incorporate the Marconi wireless transceiver. So what's so special about this transceiver is that, for one, it's an integrated design. Previous transceivers have had this, had all the parts, the ADCs, the DACs, and the processing all together, but they were individual components. And so what this does, it puts in a nice, neat package that's designed to work better together and do a nice, neat design and flows really well. Also, it helps condition the data with some digital filters that are added in, so that before it's even to the baseband where the DSP happens, the data is conditioned and it kind of helps with the speed a lot. And then it also has some built-in redundancies that will help reduce bit error rate, so you won't get as many errors. And we also have, it also incorporates some very intuitive, easy-to-use APIs for the consumers. So when the consumer buys the product, it's a lot easier and a lot more intuitive to understand what's happening and how to write and how to use these devices once they have it. So what we did in this project is we first had a huge learning curve. So that was the majority of the semester. But we learned about the device. We learned about the wireless communication theory that's behind the device. And we also we learned about how a large-scale project like this comes together in an industry setting. A lot of things like Team Foundation servers and things like that. All these softwares, programs and things like that we had to learn how to use. And then we also learned about different coding standards, because there's a lot of coding that we had to learn and review. And so we got to look at those. So what we did is we created, we looked at the 5 top-level APIs: the transmitter, the receiver, the power management unit, the phase lock loop, and the system clock. And we analyzed those APIs. We looked at them compared them for compliance with the coding standard. And we also created flowcharts out of them to confirm our knowledge. And these flowcharts will then be integrated into the Doxygen later for that. For next semester, what we plan to do is take this knowledge that we've gathered all semester and implement it into a useful area that TI seems fit. One of those areas that we might be doing is calibration and compensation. So these devices have some unwanted frequencies and unwanted images that come along with the conversion from analog to digital and demodulation and things like that. And so one of the things that we'll be doing is optimizing these calibration and compensation softwares and helping get rid of those to create a better quality signal. Any questions?
Does this radio use a MIMO technology?
Yes.
Okay, so how many antenna, how many channels are you?
We have we have two receivers and 2 transmitters per chip, and we have 2 chips. So we have 4, and then we also have an extra feedback receiver on each chip that'll help So, as I said earlier, this helps condition some of the data by knocking out some of the, like when it's demodulated, there's some harmonics and extra frequencies. And so what this is, there's some digital filters in there that will be helping create, and they exist, but we'll be helping improve them. That'll help clean the signal up before it even gets to
Is that necessarily via the development of single processing code?
Thank you, Marconi project. Congratulations.